Hello everyone, I hope you have a great and amazing day. Welcome to Bright Beginnings. Today our lesson will be on electromagnets. Let's get started. Using electromagnets. So this train floats at 311 miles per hour and it doesn't have an engine. So what do you think makes it go so fast? Lifting off at high speed. We know that magnets repel each other. We can use this to engineer levitation. So magnets can attract each other and powerful magnets on the tracks repel the train. So these powerful magnets on the track of the train, they attract the train together. This means that there is no friction. So the magnet and the train has now been attracted. This means there will be obviously no friction. So this will be, the train will move because of the attraction of the magnet. So the train is pushed forward by very powerful force of electromagnets. Electromagnets differ from normal magnets. So they're not like normal magnets, but they're way different in one major way. They are made by passing an electric current through a wire that has been wrapped around iron. So the electromagnets, the current powers up the magnet. So there is an electric current that flows through a wire which has been wrapped around iron. So the iron in this picture itself, the nail is the iron, and these are the wires that are wrapped around. Okay, so the current creates a magnetic field and magnetizes the iron core. So the iron core is in the middle of the nail or the object we have here, and the magnetic field is like the space around it, like the distance around it. So when the current is turned off, the iron loses its magnetism. So once the current will stop flowing, maybe there'll be some error somewhere here, the iron will lose its magnetism and it will turn off. Similarly, if you remove this battery, it's a way of stopping this electromagnet. So once this battery is removed, the electromagnet will turn off. Okay, example number 1. Using electromagnets in scrapyards. Electromagnets can be used to lift objects made of magnetic materials, example iron and steel. So now many of you have been seeing this this item here, this thing on these trucks here, on the cranes. These are also electromagnets. They're very huge electromagnets. So the crane has a large electromagnet which is turned on to lift scrap iron and steel and turned off to drop it somewhere else. So there will be some steel or scrap which is not needed. So the electromagnet will turn on, attracting the scrap towards the electromagnet. Then the scrap will be collected and will be dropped at somewhere else. This is an advantage of electromagnet, that you can turn it off and on. And similarly, an split ring communicator. This is the split ring communicator, and this whole thing is called as an electric motor. An electric motor uses the motor effect of electromagnets to create motion. The force on one side of the wire causes it to move up. So force over here and force over here, they move up. The force on the other side causes it to move down. So one side pulls it upwards, one side pulls it down. So this process makes the motor rotate. So here, one side is moving up, one side is moving down, continuously up, down, up, down, up, down. Then it starts rotating. This is the brush, that's the item on the motor. Like this, the motor rotates. The strength of an electromagnet depends on, so of course there will be something that the electromagnet has to depend on. It can't just be that it only has advantages. Number of turns in its coils. Coils is how many times it's going around the metal object. The more it turns around, the more there will be the power of the electromagnet. Amount of current passing through the coil. This is of course really important. If there is no current, there is no electromagnet. So the more the current, the powerful the electromagnet. So what are the uses of an electromagnet? So here are some examples I'm going to tell out to you now. They are used in appliances such as electric motors, electric fans, and electric belts. They are used in lifting heavy loads of iron and scrap, and are also used in cranes to lift vehicles. They are used to deflect beams of electrons in TVs. They are used to separate iron ores from impurities in mining industries, and they are used in relays in telephone exchanges and in computers. They are used by doctors to cure certain diseases. Okay, so what are electromagnets? So it's question now. So what are electromagnets and how can we increase the strength of an electromagnet? Oh, electromagnet. An electromagnet is a magnet that runs on electricity. Unlike a permanent magnet, the strength of an electromagnet can easily be changed by changing the amount of electric current that flows through it. So electromagnet is a magnet, of course, that runs on electricity, unlike a permanent magnet, which runs on some other force. The strength of an electromagnet can easily be changed by changing the amount of current that flows through it. So you can have your own amount of own power of the electromagnet. So number two, how can we increase the strength of an electromagnet? The strength of an electromagnet can be increased by increasing the number of loops of wire around the iron core and by increasing the current or voltage. Okay, it's quiz time now. A magnet made from current carrying wire around a magnetic metal core. A permanent magnet with the north and south pole. So of course electromagnet is a temporary magnet, so it's this one. What would increase the strength of an electromagnet? Decreasing the number of coils, increasing a wooden core, changing the direction of the current, increasing the amount of current flowing through the wire. So it will definitely be the increasing the amount of current. So the more current, the more power. What effect will south pole of one magnet have on the south pole of another magnet? They will repel each other. While electric current is flowing through a wire, what surrounds the wire? So I told you that when an electric current is flowing, the distance around it will be called as a magnetic field. What kind of magnet can be turned on and off? Electromagnet. The strength of the magnetic field of an electromagnet can be increased by increasing the number of coils, decreasing the number of coils, increasing the resistance, or decreasing the current. It's going to be increasing by the number of coils. This is a picture of a simple electromagnet here. How can the electromagnet be made can be made more stronger? Use a smaller battery, add more coils of wire to the nail. These are coils, the loops. Reverse the poles of the magnet. Remove all the coils and the nail. The most sensible answer is add more coils of wire to the nail. So the more power will flow and it will be more stronger. Surrounding every magnet is a magnetic field or an electric current or another magnet. It's going to be magnetic field, the distance around the magnet. Which of the following is not a part of an electromagnet? A toothpick, iron, power source, or wire? It's a toothpick because it's like the odd one out and it's wood. So electromagnet has nothing to do with toothpick. You can make an electromagnet stronger by having a dash current in the wire. A greener, a smaller, a water, or a larger. It's larger because the more the current, the more the power. Okay, so that was it for today's lesson. I hope you have understood something from this lesson. So please comment if you have any queries, and I'll be uploading more videos in the future.